Let me show you how we investigated the effect of grain shape on the flow of granular materials. So here is our setup. We used plexiglass sheets that we cut using a laser cutter in order to reproduce a 2D rotating drum. We filled the rotating drum with grains that we created using the same plexiglass material. The drum itself has a diameter of 20 centimeters and a thickness of 3.5 millimeters. This is slightly more than the thickness of the grains so that they can move as freely as possible inside the rotating drum. We fixed the rotating drum to a stepper motor in order to control the rotation speed of the drum. Concerning the grains, we wanted to quantify their shape, so we created 8 pointed stars with different circularities. We captured the motion of each type of grains inside the rotating drum for various rotation speeds. Then we analyzed the images in order to extract the dynamic angle of repose as well as the dilatancy of the granular bed in motion. When measuring the dynamic angle of repose, we observe at high rotation speed that the less circular grains in red on this graph reach a higher angle than circular grains. We explain that with the measurement of the dilatancy. So the dilatancy is a measurement of how the granular bed dilates once it is flowing. When the rotation speed increases, we can see that the granular bed made of non-circular grains expands more than if it was composed of circular grains. It implies that there are more and more voids in the granular bed. And so it explains why the angle is larger with non-circular grains, because these grains get trapped in the voids of the granular bed once they flow at the surface. Finally, if we come back to the measurement of the dynamic angle of repose, we also see at low rotation speed that the angle is larger with circular grains. To explain this effect, we measured the packing fraction at rest as a function of the circularity of the grains, and we can see that the circular grains reach the highest packing fraction. At low rotation speed, the angle is therefore larger for circular grains due to interparticle locking.